Hello guys, welcome to this, my video on scientific notation. My name's Darren, Maths Guru, and it is always good to see you if you've been seen before. Anyway, I'm going to go through what you can see behind me. The learning objectives are understanding what scientific notation is, how to convert from and to scientific notation. It's a huge subject and really, really important. Sadly, one of the ones that we try and trick you with. But you're going to be able to smash it by the end of this video. Can I ask a favor? Can you subscribe? It's one click of a little button for you, and it just lets me know that people are watching. Who watches maths videos? No one watches maths videos. No one ever comments on my videos. I'm sure it's just my mother signing up for multiple accounts. But if you can do that, I would be deeply, deeply grateful. Telling your mates is so, so important. Just to tell them, hey guys, I found a really good video. What do you mean you don't know it's really good? All right, chill. So those are my learning objectives. What are we doing now? Previously, we've dealt with all the index rules. So this is taking all the index rules we've had previously and the idea of floaty numbers. Yes, I know I said floaty numbers. They are numbers what float. Powers, exponents, index. Stupid. All right, so we'll take all those floaty numbers and we actually use them to write really big numbers in a much, much simpler way. Because as mathematicians, we're a little bit lazy, actually. We don't want to be writing out hundreds of zeros. In fact, we can't. We'd be here forever. What would we achieve? So scientific notation gives us an easy way to express big numbers. That's it. All right, so let's have a look at what we can break this down into. Now we know that, as I say here, the number 400 has got 4 and 2 zeros. Well, we like numbers that have zeros in them. Why? Because we can actually write that as 4 times 100. And we know that 100 is one of those special numbers that can written as 10 times 10. In fact, any power of zero, any 100,000, 10,000, whatever else, can be written as 10 times 10 times 10 times 10 as often as we need to. Okay, so how is that helping us? Well, again, taking the work that we've done on index notation, and again, we always seem to do it with letters, not so much with numbers. We can write this as 4 times 10 to the floaty 2. And absolutely, ladies and gentlemen, ka-ching, there we go. That is standard form or scientific notation, all right? Totally different names, totally the same thing. We have turned 400 into 4 times 10 squared. And you're going to say, why on earth would I want to do that? Why don't I just write 400? That seems to be longer. I know. And for some numbers, it does seem a little pointless. But for big numbers, it is very, very important. For example, if I wanted to write this number here, which I have absolutely no idea what it actually is, maybe write in YouTube what you think it is, that's a lot of zeros. I'm not going to write that all the time, am I? But what if I could write that as 4 times 10 to the floaty 3, 6, 9, 12, 15, 18. There we go. That's a lot shorter than that massive number there. And that's why we do scientific notation. And if I call it standard form, it's just because that's what we call it in the United Kingdom, right? Scientific notation or index notation or whatever else, all the same thing. Now, standard form gets tricky because people get tricked with this. And you're going to say, how can I get tricked with this? And I'm like, well, because there is a rule. And the rule is that standard form, or scientific notation, has some sort of number before a times and a 10. All scientific notation have that notation. There is a number here. I'll explain more about that in a moment. There's always this times by 10, and there is always a floaty number that can be both positive or negative. Now, what I say here is so very important. This decimal number, and you're going to turn around and say, but hold on, that last number wasn't decimal. Well, 4 times 10 to the floaty 2 is exactly the same as 4.0 times 10 to the floaty 2. All right, so realistically speaking, that is a decimal number, but we just don't put the 0.0. So this decimal number here can never start with a 0. Right? It can never start with a 0. We would always put, as I say here, a decimal point between our first 2 non-zero numbers. And I'm going to explain what that means in now with some examples. So if we look at the examples on the screen now, they are good examples of scientific notation. You're going to turn around and say, what are you talking about? Notice we've got a decimal number. The decimal point is between 2 numbers, again, times 10 to the floaty 3. It's got everything we need. A decimal number, it's got the times 10, and it's got a power or a floaty number. The next one, 7.34 times 10 to the negative 2. Again, it's got this times 10. It's got the floating number. It's got a decimal point between the first two non-zero numbers. And you're going to keep telling myself, but there's no zeros there. They're coming. Chill. And again, 4.0 times 10 to the 23. These are all good examples of standard form or scientific notation. Can you see now why these are bad examples? All right. So with the first one we've got is 0.2 times 10 to the floaty 3. We've got the times 10. That's good. We've got a power. That's good. Uh-oh. It is never allowed to start with a 0. So that decimal point is actually in the wrong place. And I'll explain again what that means in just a moment. What about 73.4 times 10 to the minus 2? Well, we know the times 10 is needed. The floaty power is needed. Is my decimal point in front of the first two numbers? Nah. So that decimal point's in the wrong place. Now, although it's wrong, we can go on and correct it. We can reformat it a little bit later on. And likewise, what have we got here? 400.0 times 10 to the power of 13. Again, that decimal point is on the wrong place. I will guarantee you that if you ever do a test on this, there'll be a question in there where they give you wrong values, all right, and ask you what's wrong with it. Now you're going to know. All right, so firstly, let's convert into scientific notation. Oh, right, let's see. So we've got 45000000. All right, so how am I going to do this? Well, what I need to do is realize that at this moment in time, 450000 has a decimal point. You're going to say, no, it hasn't. I'm going to say, yes, it has. At this moment in point, there's a decimal point at the end. We know that all whole numbers have a decimal point at the end. And what does scientific notation tell us we've got to do? We have to move that to between the first two non-zero numbers. So basically my decimal point's got to move between the 4 and the 5. Now, again, I love doing this. It's bouncing decimals. It's literally bouncing decimals. I'm going to see how many times do I have to move that decimal point to get it between the 4 and the 5. So we're going to go 1, 2, 3, 4, 5, 6 times. So my decimal point's going to end up between the 4 and the 5. And I've moved it 6 places, right? Now, what that means is that I can do times 10 to the floaty 6. And you're going to say, whoa, 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 whoa. Now, let's just backtrack a moment then. So we've got 4.5 times 10 to the floaty 6. Well, we know that's times 10, times 10, times 10, times 10, times 10. 1, 2, 3, 4, 5, times 10. And if we do the 4.5 times 10 times 10. Remember, you're bouncing. Whenever you times by 10, which way are you moving your decimal point? Aha. So when you multiply by 10, you move it to the right, don't you? Yeah? And when you divide by 10, you move it to the left. So what we're really saying is that to be able to move this decimal point to between the 4 and the 5, I'm dividing that number by 6 lots of 10 times 10 times 10. Or I can rewrite it as 4.5 times 10 to the floaty 6. What? I know. Now I'm going to do some more examples, but that's pretty much the essence of this. So if I look at this example now, we've got a decimal point between two zeros. Are we allowed that in standard index form? No. So where have we got to move it to? Well, the first number can't be a 0. And there's only one number in there that's not a 0, and that is indeed the 4. So I've got to move my decimal point to after the 4. So that's going to become 4 times 10. Well, if we move the number this way and the power was positive, if we move the number that way, the power must be negative. And again, I'm just counting how many times my decimal point jumps. So let's see. 1, 2, 3, 4, 5, 6, and 7, we'll put it there. So that's actually 4 times 10 to the minus 7. Standard index form. Now you're going to be like, I have no idea what you're doing. And I'm like, I get it. Trust me, it takes practice. But when you get this, you'll be like, I'm gun at this. So when we are converting to scientific notation, what we means is that a positive power, so where we've got this times 10, this number here, where that is positive, it means we've moved the decimal point to the left, all right? So when it's positive, we have moved the decimal point to the left. So positive, moved left. And when it is negative, when that value there is negative, it means we've moved the decimal point to the right. Now, why is this going to be important? Because we're going to undo it in a minute. Now, if ever you need to sign up to maffsguru.com, it's free to sign up, and you can download these exact notes that I'm writing on now. Right? So you can download them, put them in your summary book, write out what you need to do. I'm here to try and help you. So let's look at some examples of converting now back into decimal form, and then we'll do some mixed examples in a moment. So we've now got standard form. We've got 9.34 times 10 to the floaty 5. Now to convert it, when we had powers, when we had positive powers, remember, when we put it into that, we moved it left. So we've got a positive power. I want to undo it. Which way am I going to move my decimal point? To the right, to the right, to the, no, anyway. So how many places am I going to move it? Well, 5. The floating numbers are 5. Let's move it 5 places. Right, 1, 2, 3, 4, 5. So that's where my decimal point now moves, 2. And next thing I say, well, hold on a moment. It's jumped over 3 spaces. What's there? And normally I say to my kids, what's there? And they go, nothing. And I go, exactly. There is absolutely nothing there. There is nothing there. And there is nothing there. So bearing in mind that decimal point now doesn't exist because it's moved, my number has become 93400. And if you don't believe me, again, that floaty 5 says if I take this decimal point and move it 5 places backwards, do I get 9.34? I should go. Now an example of the negatives. Remember, when the value is negative, we moved it to the right. Yes, so negative, we moved it to the right to convert it into standard form. So we have to do the reverse of that. So I'm going to write my number 4.71. I've got minus 5, which basically tells me now I'm going to move it that way. Hopefully I've done that right for the camera. 5 places. 1, 2, 3, 4, 5. That's where my decimal point now becomes. It's gone from there. A lot of people say to me, do I have to write the little jumpy bits or can I do it in my head? Well, you can try and do it in your head, but I can guarantee the chances are you're going to make a mistake. And literally, how long did it take me to do those jumpy bits? Not very long at all, really. So what have I got here? Nothing. 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 And this is where I get lots of comments on my YouTube channel where people go, my teacher told me. Well, no. You might now think that that answer becomes 0.0000471. No. If anyone ever tells you that you can have that decimal point floating at the front, I'm really, really sorry, you're wrong. They're wrong. You have to have a 0 in front of it. It doesn't make any sense. And more importantly, if you just leave that dot hanging there, an examiner might miss it or wonder who on earth it is teaching you maths. There we go. So 0.0000471 will be my correct answer. All right, so again, this is just notes for you if you want to copy this out from your summary book or wherever you want to put it, yes? I always remember one rule and just learn how to reverse it. So it says a positive power means that we move the decimal point to the right. All right, so a positive power means move it to the right to go back to the normal number, and a negative number means move it to the left. Okay, think about how this might be more complicated. So let's look at, this is a bit of an extension. I'm sure there's more to this video that you can skip. So if I have 400 times 300, you put that into your calculator, we know that's going to become 120000. And if you now remember how to write that in standard index form, we've got a decimal point here. I'm going to move it 1, 2, 3, 4, 5 places. That becomes 1.2 times 10 to the floaty 5. Right, so doing it the old-fashioned way, but can we now think about it using scientific notation or index notation? Now we know that 400 can be written as 4 times 10 to the floaty 2. I'm going to put that in brackets for a moment. And 300 can be written as 3 times 10 to the floaty 2. Now the brackets are there just to show me the scientific notation, but actually we don't need them because that's 4 times 10 to the floaty 2 times 3 times 10 to the floaty 2. And you're going to say, well, hold on a moment, you've written the same thing. But what do you know about things that are multiplied together? Well, if they're all multiplied together, they can actually move around. We can change the order of these things. So I'm now going to write that as 4 times 3 times 10 to the floaty 2 times 10 to the float. You're kidding me. We've got some index notation stuff here. We've got some floaty numbers. What is timesing? And we absolutely do. So there we go. What do we notice? Well, when we have two bases that are the same, that are multiplied together, we add the power. So that becomes 10 to the floaty 4. And we know that 4 times 3 is 12. And lo and behold, there we go. We have a, no, we don't. We don't have a standard index form number quite. Why? Because where's the decimal point at the moment? It's after the 2. So I'm going to have to move it one more place to the left. So when I move that one more place to the left, what do I have to do to my floaty number? Add one more. Exactly. And so you're going to turn around and say, well, that was flipping long. I'd rather do it the easy way. Yes, I know, but you're going to have questions in a minute that's going to try and trick you and do it the hard way, right? If we look at the same idea here, as what is that? 400,000 divided by 2,000. All right, so again, if we were going to do this the hard way or the long-winded way or the usual way, we can cancel a 0 from the top and the bottom, a 0 from the top and the bottom, and you keep going, and we're done. We can cancel a 2 there into a 4 there. That gives me 2. So when I divide those together, I get 200, which as a standard form number is 2 times 10 to the 2, scientific notation. Can we do the same thing now with scientific notation? Let's put the numbers straight into scientific notation. So that's going to be 4 times 10 to the power of 5 divided by 2 times 10 to the floaty 3. Now again, when we multiply, we can cross cancel, we can do what we need to do. And what we notice is we've got 3 10s on the bottom, which will cancel with 5 or 3 of those to leave me 10. We have 2's go into there once, 2's go into there twice, and lo and behold, what do we notice? Well, the bottom's 1 times 1, so we don't need to worry about that one. And the top becomes 2 times 10 to the floaty 2. Ka-ching. Again, it's just there for you for some sort of extension work if you need to. Now, there are lots and lots of questions out there that can be done with converting into scientific notation. If I use this screen again, that won't make any sense because I don't have any more screens available to me. If I have the number 23746 and I want to convert that to style, again, I've got my decimal point here. I'm going to go 1, 2, 3, 4. Now, people go to me, well, do I miss out any of those decimal places now? No, they all get written. It becomes 2.3746 times 10 to the minus, times 10 to the floaty 4. Again, don't do it, it's not minus, it's plus. What other number can we have? 0.00207. Again, people get confused with this one because I'm now going to move my decimal point to the right. So it's going to be a negative floaty number. So I've got times 10 to some negative floaty number. It's going to move how many places? Where am I going to put my decimal point? After the 2 or after the 7? Well, hopefully you've answered after the 2 because it has to go after the first non-zero number. So it's only going to go 1, 2, 3 places. So firstly, that's minus 3. And what number am I going to write down there? Well, I'm going to write down 2.07. Now, my advice, and I always tell my students here, is don't round those numbers. Although that is a decimal there, do not round it. You don't need to round it because you suddenly change the number if you round it. Right? Writing it in scientific notation is just another way of writing a number in a different way. Don't round it. Can I think of another example? 40723. What would we do here? Well, it's a positive value, or it's going to basically move to the left. So 1, 2, 3, 4 places is going to put it there. So there's my floaty 4. And I'm going to write 4.0723. All of those values would get written down. And there we go, that's it for this video. Thank you very much for watching Scientific Notation. There will be other videos in this series coming up because Scientific Notation is quite big, and I maybe will do another video extending it out, showing you how more complicated examples can be done. Watch this space. Otherwise, thank you very much for watching. My name's Darren. Please subscribe. Please tell your mates. All right, it's one click to you. It means the world to me. And comment, let me know how you found the video. Otherwise, hopefully I'll see you in another video. Take care, guys. I'll see you again soon.